Hello and welcome. In this session, we'll discuss examples of the material substitution strategies to reduce material demand for PV. The silver-looking wires you can see are indeed made mostly of silver. They serve an important function of transporting the current. Despite only using 5 grams of silver per square meter of PV module, the PV sector uses about 14 to 19% of the global annual silver production. Indium is used in transparent conductive oxides, or TCOs in short. While TCOs are only 50 to 100 nanometers thick, there are not enough indium reserves to produce 50 terawatt of PV modules with indium-based TCOs. So what can we do to solve these challenges? We can substitute silver screen printing with copper screen printing or copper plating. This has the advantage that copper is more abundant and annual production is significantly higher. Additionally, it's also cheaper. Disadvantages are that copper is listed as a critical raw material according to the 2023 EU list, while silver is not. This has the effect that different regulations apply. In the past, solar cells with silver were more efficient and stable. However, engineering advances have closed the gap to the point that recently more new PV factories use copper and not silver. So what is the impact of substituting silver with copper? The black dashed line shows the increase in annual PV deployment to an estimated 5 terawatt annually till 2050. The gray line is the estimated annual silver supply. The orange reference scenario shows how much silver would be needed if this is done with the current PV technologies. This scenario is exceeding the silver production in the late 2030s. The blue line shows what would happen with continuous optimization to PV and silver use along historical trends, while the green copper substitution scenario shows how PV-related silver demand could be kept stable while increasing production by a factor of 10. So that would be a solved problem and a success story for substitution. Let's knock on wood. As mentioned, indium is used in transparent conductive oxides, which are present in some solar cell technologies, such as silicon heterojunction or SHJ. In short, if silicon heterojunction solar cells are deployed, then we need to reduce or replace the indium in those solar cells. Another option is to avoid the silicon heterojunction technologies and use TOPCon solar cells instead. These are indium-free by design. So this is an example of changing the design to avoid using certain materials such as indium. To wrap up this video, we learned that in PV technology we can substitute silver with copper metallization for current transport, and that we need to either use inherently indium-free solar cells such as TOPCon or develop indium-free silicon heterojunction solar cells. As we continue this course, we'll explore how other circular strategies can be applied in the PV sector. Thank you and see you in the next session.